Hey there, grade six. New video for you guys today. This one focuses on something called graphing sequences. It's the next lesson in our patterns and algebra unit. And so hopefully by the end of this lesson, you'll be able to say that I can graph sequences and determine if the graph shows an increasing or decreasing sequence. And so where we're going to start with this is just to quickly review coordinate grids. And so what you'll see here is something called the coordinate grid. And the way it works is that you put points on the coordinate grid, you need something called an ordered pair. The first number in our ordered pair is called the x-coordinate. It tells you how far to the right you're going to go. Then there is the y-coordinates. The second number in the ordered pair tells you how high or how far up to go. And so those are ordered pairs. And so if we have something like I don't know, let's see. If we have something like 2, 5, then we are going to move. So the first number tells us to go 1, 2 to the right, and then up 1, 2, 3, 4, 5. And then we can put a point right here, and that's going to be 2, 5. And if you want, you can actually put the coordinates beside it if you'd like. You don't have to, but that's something that I've been shown before. Anyway, so that's just a quick review of coordinate grids. And then so where we move on to from that is to looking at sequences of numbers and writing that sequence as a set of ordered pairs. So we can think of a sequence as a set of ordered pairs in the form of term number and the term. Now, for example, the term numbers will always just go like 1, 2, 3, 4, 5, so on and so forth, okay? And then here we see this sequence of numbers, 1, 3, 5, 7, 9, that goes into the term column, 1, 3, 5, 7, 9. And so we put this in what's called the sequence table. And so we filled it in, we have the term numbers and then the terms in the right-hand column, okay? Just see what's down here for a quick sec. And so if we were to write out all these, so what we can do then is from creating a table of values or a sequence table, we can start writing them as ordered pairs. And so we can say, well, term 1 has the term of 3, term 2 is 3, term 3 is 5, term 4 is 7, and term 5 is 9. And so actually, let's go through a couple exercises. So they want us to write a sequence as a set of ordered pairs. And so again, we have our term number and then our term over here. I'm going to make it a little bit simpler than this. So we have 1, 2, 3, 4, 5. I will extend my line here. And then for the first term is 4, second term is 6, third term is 8, fourth term is 10, fifth term is 12. Likewise over here, I have my term number and I have my term, split that up into like a sequence table. And I've got 1, 2, 3, 4, 5 terms to list. And then term 1 is 13, term 2 is 10, term 3 is 7, then 4, and then 1. Now, I wonder if anyone noticed anything about the second sequence table or the second set of ordered pairs, because we can actually create these as ordered pairs. I'm just going to change the color of the marker for a second. So we'd have 1, 4, 2, 6, 3, 8, 4, 10, and 5, 12. And then over here for this one, I'll just do it up here. We have 1, 13, 2, 10, 3, 7, 4, 4, and 5, 1. Now, I don't know if anyone noticed this, but the term in the second set of ordered pairs is actually decreasing, which is possible. And the reason that's something to note is that one of our learning targets is that we can see if a series is going to be increasing or decreasing. Because what we can do with this stuff, these ordered pairs, is we can actually plot it on a coordinate grid. And so that's going to get us over to actually graphing sequences. Now, to graph a sequence, we change it to a set of ordered pairs, and then we plot the ordered pairs. So for example, here's this pattern, 1, 3, 5, 7, 9. We know that we can turn these into ordered pairs. right? And then once we have the ordered pairs, what we can actually do is we can say, okay, so that's 1, 1 is my first ordered pair. Then I have 2, 3, and then I have 3, 5, and then I have 4, 7, and then I have 5, 9. And so this is an increasing sequence. Okay, again, in an ordered pair, the first number tells us how far to go right, and the second number tells us how far to go up. So the increasing sequence means that the numbers will go to the right and up diagonally. Okay, so that's important to remember. Where we can go from there is that you can start looking at creating ordered pairs from pattern rules. And so what I mean by that is, if you have the example of add 3 to the term number. So let's just, I'm going to change color over here for a quick second again. So let's say we have our term number is on the left side, and then our term is on the right side. And let's say we have the first, I don't know, the first 5 numbers. 1, 2, 3, 4, 5. The term rule says to add 3. And so what I can do is say, okay, so term number plus 3 is 4. Term number plus 3 is 5. Term number plus 3 is 6. Term number plus 3 is 7. Term number plus 3 is 8. And so that is how we would generate a sequence using a pattern rule. And then we know what we can do is we can create ordered pairs from these. And then what we can do is we can plot them out onto our coordinate, oh, that should be a 6, our coordinate grid. And then what we can do is look at whether or not it's an increasing or decreasing pattern. I bet you can figure it out already. It's not super tricky. We have 1, 4, 2, 5, 3, 6, 4, 7, 5, 8. And because it's going up and to the right, we can say that it's an increasing pattern. So just a couple of exercises to practice that out using a term rule. So if we have double the term number, again, we're going to use the first 5 numbers. See if I can write a little smaller. So we have our term number and then our term. We have 1, 2, 3, 4, 5 squished in. Double the term number. So the double of 1 is 2, and then double that, double that, double that, and squished in is double that. So those are our term numbers, right? And then what we can do is we can create ordered pairs from that, right? We have 2, 4, 3, 6, 4, 8, and 5, 10. Over here, it's going to say triple. It says triple the term number and then subtract 3. So again, have my term number and term. 1, 2, 3, 4, 5. So triple the number, subtract 3. So 1 times 3 is 3. Subtract 2 is 1. 2 times 3 is 6. Subtract 3 is 3. 3 times 3 is 9. Subtract 3 is 6. 4 times 3 is 12. Subtract 3 is 9. And 5 times 3 is 15. Subtract 3 is 12. And so again, I can generate ordered pairs. I have 1, 1. I have 2, 3. I have 3, 6. I have 4, 9. And I have 5, 12. And then what we can actually do is to graph them out over here on our graph. Okay, so the first one over here, we have 1, 2. So this is doubled, right? So all these 2 different colors. We have 1, 2. We have 2, 4. We have 3, 6. We have 4, 8. And we have 5, 10. And so that, again, if you look, that is an increasing pattern. It's going up and to the right. And then for our second pattern, our first one was 1, 1, and then 2, 3. So here's 1, 1. Here's 2, 3. Then we would have 3, 6, 4, 9. So we have 3, 6. And we have 4, 9. And then we had 5. I don't even have enough room up here. It was 5, 12. So that's that, until 12 will be up here. Now, interestingly enough, I hope what we notice is that even though the second pattern starts lower, it actually increases more quickly and has a sharper, it goes up and to the right more quickly than the blue dots. And you can kind of see that if you were to sort of like connect them and see how the lines kind of go up like that. You can kind of keep going up. Whereas if you were to draw a line on the second one, or the first set of numbers that we did, it would look roughly like this. and then kind of keep going. So that's how those two lines would look different. Anyway, that's it in terms of like graphing sequences. The practice is 3 pages today. It's 86, 87, and 88. And it says that right here. And so again, thanks for watching. Bit shorter video today, but happy mathing.